Hi everyone. Today we're going to study binomial probability distribution. Let us define binomial experiment. A binomial experiment is a probability experiment that satisfies the following. Number one, there are only two outcomes, namely success or failure. Number two, there must be fixed number of trials. Number three, the outcomes of each trial must be independent. Number four, the probability of success remains same for each trial. For example, tossing a coin, the outcomes are head or tail, is a binomial experiment. It means this experiment satisfies these four conditions. The probability distribution of a binomial experiment is called binomial distribution. Probability formula for binomial distribution. In a binomial experiment, the probability for exactly R success in n trials is this. P of capital X equals R equals combination of n taken R at a time times P raised to a power R times Q raised to a power n minus R. Take note, the P is equal to the probability of success, and this Q is the probability of failure, and the formula for Q equals 1 minus P. Take note also that the mean is equal to this symbol E of X, which is the expected value, and this is equal to n times P, while the variance denoted by var of X equals n times P times Q. Let us see this example. Identical computer components are shipped in boxes of 5. About 15% of components have defects. Boxes are tested in a random order. What is the probability that a randomly selected box has only non-defective components? For our solution, let us list the given. Take note, we let capital X be the number of non-defective components in a box. The n is equal to 5. Given here is the Q, or the probability of failure, and that is 15%. And we write 0.15. From Q, we can compute for the P, and this P is the probability of success. The formula is 1 minus Q. Substituting the value, we have now 1 minus 0.15, and the P equals 0.85. Again, P is the probability of success. The formula is here. Again, we say that X, that is the number of non-defective components in a box. So, the probability of a box with 5 non-defective components is, it means the R equals 5. Substituting the corresponding values in this formula, we have now P of the capital X equals 5 equals combination of 5 taken all at a time times the P now is 0.85 raised to R, and that is 5, times the Q, which is 0.15 raised to N minus R, and this is 5 minus 5 in the power. Simplifying further, we have this 5 combination of 5 equals 1. We keep the 0.85 raised to 5 the same, and the power 5 minus 5 here is 0. We can simplify further because the 0.15 is raised to 0. We can make this also as 1. And the final answer for this is 0.44. This is the probability that a randomly selected box has all non-defective components. This is our final answer. Today we're going to study Poisson probability distribution. Let us define Poisson probability distribution. A Poisson distribution is a probability distribution that is used to show how many times an event is likely to occur over a specified period. In other words, it is a count distribution. Poisson distributions are often used to understand independent events that occur at a constant rate within a given interval of time. For the Poisson distribution, which is a discrete distribution, the variable can only take the values 0, 1, 2, 3, etc. with no fractions or decimals. It was named after French mathematician Simeon Denis Poisson. For the formula of the Poisson probability distribution, we say that Poisson distribution is useful when n is large and p is small. The probability formula for Poisson distribution is here. P of capital X equals small r equals this fraction where the numerator is the exponential raised to negative lambda times the lambda raised to r, and the denominator is r factorial, where the lambda is the mean and r are values from 0, 1, 2, and so on. For a Poisson distribution, the expected value is equal to lambda and the variance of x is equal to lambda. Let us see this example. Suppose that the number of inquiries arriving at a certain interactive system follows a Poisson distribution with arrival rate of 12 inquiries per minute. Find the probability of 10 inquiries arriving, letter A, in a 1-minute interval. Letter B, in a 3-minute interval. Letter C, what is the expectation and the variance of the number of arrivals during each of these intervals? For our solution, let us collect the given of the problem. The lambda is that mean and it is equal to 12 per minute. The R is this value 10. Now, the formula for the Poisson is here. Let us solve for letter A. Let capital X be the number of inquiries in a 1-minute interval. Then, capital X is a Poisson random variable with the parameter 12. Substituting the values for this formula, we have now the probability of capital X equals 10 equals exponential raised to negative lambda, and that is now negative 12, times the lambda raised to r, so we have here 12 raised to 10, all over 10 factorial. Using our calculator, let us combine these two values in the numerator as 380,433.4342, while 10 factorial is 3,628,800. The quotient now is 0.1048. This is our answer. Let us copy this answer under letter A problem here. Here we go. Now let us solve for letter B. Let capital X be the number of inquiries in a 3-minute interval. Then X is a Poisson random variable with the parameter 36. So these 3 minutes we multiply by 12. The 36 is here. Using this formula now, we have the P of capital X equals 10 equals e raised to negative 36 times 36 raised to 10 all over 10 factorial. Simplifying the numerator, we have this value 0.8480543 all over the 10 factorial, which is of this value. The quotient now is this 0.0000002337. This is the answer for problem B. Let us copy this answer under problem B here. Let us now solve for problem C. What is the expectation and the variance of the number of arrivals during each of these intervals? For Poisson distribution with parameter lambda, the expected value is equal to the variance of x, and that is equal to lambda. Therefore, for a 1-minute interval, the expected value and the variance is equal to 12. For a 3-minute interval, the expected value and the variance are all equal to 36. This is our answer for letter C. Let us copy this answer under problem C. So we are done with our answers for this example. These are our final answers. I hope you learned something from this video. See you again next time.